Hello everybody, my name is Luis Kruger, and I want to thank you first of all for giving me this opportunity to talk to you from Sydney. I would much prefer to be in Barcelona at the moment, but I'm going to talk to you very briefly today about the use of eye tracking in media accessibility research, and I'm going to focus in particular on word level data in subtitle reading. Now, eye tracking is of course very useful in our field, and especially for giving us a better sense of how people engage with audiovisual texts and contexts, where they look, which gives us an idea of what they're processing. And it's of course not new, we've been using it for a long time. Dieter Waller and colleagues started using it in the 1980s to look at how people read subtitles, and it's become more and more sophisticated as technology improved and as our understanding of these measures improved. And of course we have a much broader field to draw on in cognitive psychology in particular, where the study of reading has developed massively over the past 20-30 years. Now, in the context of audiovisual translation, of subtitling, of media accessibility, eye tracking has really been used predominantly to give us a sense of how people distribute their attention between the image and the text. And we've seen a number of studies appear in the last decade or so that deal with how this attention is distributed, what competition there is, but also how people, to what extent people can actually read the subtitles and also still make sense of what they see in the visuals in the film. We've been using it more and more to look at things like cognitive load, at the impact of different characteristics of the text on the reading of the subtitles, and all of these have given us a lot of insight into how people engage with subtitles, how changing the layout or the speed of subtitles impact on the way people read subtitles and watch film. Now, eye tracking is important because, unlike what we might think, we don't really see a lot of what's in front of us in high definition. Now, when you're looking at a static scene, or something like this, a scene that stays static for like a slide for a relatively long period of time, you have enough time to explore everything and to form kind of a mental image of everything that you see and how it coheres. When you deal with multimodal texts and with dynamic multimodal texts like film, however, it's not quite that simple because of the fact that visual attention is very limited. We can only really see about 2 degrees, or the size of a thumbnail if you put out your arm, at any given time. And we can illustrate this fairly easily if we look at something like this. If you look at that sentence and you only focus on the first word, just, then there's no way without shifting your eyes that you can make out anything much further than perhaps the third word, much. The rest you can only see if you shift your view. And it looks something like this. If you looked at much, you can see a little bit to the left, a little bit to the right, but then it starts becoming more and more blurry. Now, of course, it doesn't look exactly like this, but this just illustrates it. And then you have to move your eyes progressively through the text to be able to see how people, or to be able to read the entire text. If we look at audiovisual texts or at multimodality and multimodal text, then you see something similar. When you have a video of something on screen, like let's say a kangaroo, because I'm talking to you from Australia, you will see, you identify the kangaroo, and that's all you need to do. You can look at the kangaroo, and then you have to start looking down at the text to start reading it. Then, of course, your vision limits how you can read that. You need to spend a particular amount of time on each of the words in order to process the text as a whole, commit that whole phrase to your short-term memory, and then you can return to the image. At the same time, if something were to change rapidly on screen, you have what we call attentional blindness, which means that looking down at the subtitle, you can still remember what you saw and you can track some movement, but you can't make out a lot of detail. So if you have somebody speaking, for example, and you don't look at their face, you won't be able to pick up on any of the non-verbal cues if you don't look at that directly, or if something suddenly moves on screen. And this is important for what I'm talking about today, which is the importance of extracting not only global average data, but also looking at very specific data at particular areas of interest on screen. Now, as I said, I'm not going to pay a lot of time or use a lot of time to discuss with you what eye tracking is, how it works, how you use the methodology, because there are some workshops during this event where you'll get a lot of very detailed information from people with much more experience than I am in the use of eye tracking. But if we look at the measures that are typically used in eye tracking, we have some measures that are typically used, and many of these measures are global measures. In other words, it collates and collects all of the eye tracking data across the entire clip or scene that you're using, and we can talk about what would be a useful duration for clip later on if there's time. But the common measures are things like the average time people spent on the subtitles versus the video, the number of fixations in the subtitle area, the average fixation duration of the fixations that were made on the words in the subtitles, and maybe the dwell time, how much time people spent looking at the subtitles, sometimes as a percentage of the time that those subtitles were on screen. And then you have some less common measures, eye tracking measures, and they include things like word skipping rates during first pass reading in particular, and this is where it becomes really important to have very high precision and accurate eye trackers with a high sampling rate to distinguish not only between the total amount of time people spent looking at the text, but to disentangle the first pass. So when you first scan a sentence, your first reading of a sentence, what the eye behavior was during that time, for example, the fixation count, fixation durations, but then also looking at the total time, which then includes things like people regressing to low frequency words, to unfamiliar words, or to clarify something in the sentence. So these are measures that are less common, and they require better equipment also, typically. And then we have local measures. Now, for the local measures, you really need to have an eye tracker or an eye tracking design, experimental design, that allows you to extract word level data. And this is tricky. If you use SR iLink, for example, then you can program an experiment where you have individual areas of interest automatically drawn around words. If you're using any of the other eye trackers like Tobii, SMI, and the others, you typically can't do that. You have to go and draw areas of interest manually around every word, and you can imagine if you're going to go into any lengthy experiment, that becomes tricky, and also the accuracy becomes really important, because if you've worked with eye tracking before, you will know that it's not necessary. It's so exact that it's not very exact. In other words, there's a healthy margin of error, and there's drift, which means that you don't always capture exactly where people are looking, and this is tricky, and you need really good software, really good hardware, high sampling rates, and then you need to clean that data thoroughly in order to make sure that you're actually describing or discussing the data that are relevant to a particular area, and not something that's adjacent to it. Okay, so word level measures that you can then look at is what happens to reading and to eye movements like fixation duration, fixation counts, if there is a word that's less common, less frequent. How do people engage with that? How do we engage with longer words versus shorter words? And also, what is the effect of, what is the wrap-up effect? Now, wrap-up effect is, simply put, just the slightly longer dwell time at the end of a sentence or a phrase where people commit that sentence into memory. Now you can see something like that in static reading. In subtitles it becomes more tricky. But we expect in low frequency words and the same with longer words, that there will be more fixations. These fixations typically are longer, and also you have more regressions to those words, more refixations. What I'm going to discuss very briefly is a framework that we formulated in our lab at Macquarie University, the Multimodal Integrated Language Framework, which provides a theoretical framework for how we can look at the reading of subtitles, and I'll get to that in a moment. Now, without an objective measure like eye tracking, of course, it becomes really tricky for us to say anything robust about whether subtitle reading improves comprehension, whether it reduces cognitive load, whether it increases immersion. Eye tracking very clearly reveals where people are looking, but also importantly how they read subtitles or how they read text. And this remains indirect if we only look at the global measures that I've mentioned, like average dwell time, average fixation count, average fixation duration, the number of crossovers between image and subtitle. And we need to have word level data, more accurate data at the word level, if we want to also answer questions about the impacts of things like first language versus second language subtitles, the layout, speed, and attention distribution, which you can still answer just with global measures. But if you want to start looking at how many words were actually fixated or processed, you need word level data, so you can see how many words were skipped. You can use something like the RIDT, which is the reading index for dynamic texts that we developed a while ago, but that's only really estimating to what extent people are reading, because you don't have word level data. If you have word level data, you can look at fixation counts and skipping probabilities on, or you can look at skipping of individual words and not just guess. You can, if you have word level data, you can get more information on skimming versus more attentive reading. You get information on refixation, so which words were actually fixated more than once, and how many regressions there were to specific words. And this becomes important because we know that for reading comprehension to occur, the normal reader, a skilled, proficient reader, typically revisits quite a high percentage of words. In other words, goes back, reads a sentence, but goes back to specific words to clarify the meaning. So if we start answering questions like this, as I said, we need more local word level data, and that's essentially what this is about. Now, I'm not going to explain how SRI link works, but it looks something like this. You have in that sentence, which is not there at the moment, but you can then get a little area of interest that's automatically drawn with a line in the boundary between the different words. Of course, there's a small margin of error there, and that is something that you then need to clean up in before you start analyzing the data. But this is useful, and this is the first time we've really started looking at a large scale at how individual words are processed. Now, if you look at subtitles, a big problem, and the reason we need word level data, is really that if you consider it, subtitles are not consistent. They don't all conform to exactly the same rules. So they vary. They're variable in terms of their layout, 1 line, 2 lines, etc., 3 lines sometimes. In terms of the volume of text in each subtitle, they vary in terms of the linguistic complexity, which you can measure with something like cometrics. They vary in terms of presentation speed, and also in terms of their competition with other input, how important or how complicated the visual scene is, for example, at the time that the subtitle is on screen. Now, to illustrate this, we did a quick sample from 2 sources: Coursera, about 11 clips of roughly 16 minutes each, and then Netflix, where we had about 10 blockbuster movies and full feature-length films. And as you can see there is a huge variability in terms of the presentation speed of subtitles. In Coursera, average fixation or subtitle speeds around 16 characters per second in the sample, ranging from about 1 character per second to more than 50, and 16% of these subtitles are faster than 20 characters per second. If you, when we looked at Netflix, we found lower average fixation or presentation speed around 12 and a half, but again a minimum of about less than 1 character per second and a maximum of over 50 characters per second, and again 15% of these subtitles faster than 20 characters per second. So it means that it's really tricky to simply extrapolate information that we get on one clip, especially if you start saying things about speed in terms of things like layout and other technical aspects. Now, if we look at audiovisual translation and multimodality, it's important to keep in mind that whatever information we get when we read subtitles or when we watch a subtitled film is not really only dependent on what's in the text of the subtitles. It depends on how much access you have to the auditory input, to the soundtrack. It depends on your language proficiency, on the relevance of what's on screen for what you're reading, and in other words, the redundancy between the different sources of information. And viewers have to constantly shift between these sources of information and use continuous and dynamic strategic reading while also then processing these other sources of information at the same time. And this means that everything goes swimmingly until you encounter a problem. So if you have the soundtrack and you understand, you have your hearing and you understand the language and you have the subtitles, then involuntarily you will compare what you hear with what you see. And then if there's a problem like here, where instead of fishing for compliments, subtitle said fishing for condoms, that word will clearly be out of context, and that will draw your attention, and that draws your attention away from other sources of information. Now, the multimodal integrated language framework that we're busy validating essentially works on the basis that when you read subtitles, you of course sequentially process the words, but you also draw on information that you extracted from looking at the image, and you can then track the movement of items in your peripheral vision, like the image of a polar bear and the image of the den. And then when you read "she has been in her den the whole winter," you know that her refers to the polar bear, and you know what the den looks like, and it helps you to index location. It helps you to bind certain features in the sentence. It helps you with word identification, object identification in your declarative memory, and then all of that feeds into your situation model and your text base that's held in your working memory. And this is where your sentence processing then also feeds in. And at the same time, you have verbal input from your auditory channel. And this is a useful image to keep in mind when you study subtitle reading, because we often tend to forget about the fact that we not only reading the text, but you actually reading that sometimes in a less than linear way. You interrupt your reading by also looking at other elements. Now, to illustrate this, I'm going to very briefly go through an experiment we did on subtitle speed. And the background for this, of course, is that there is this is quite a contentious issue. We've had quite a few people publish on this, and as you probably familiar with most of those studies. But if you consider subtitle speed, it ranges quite widely. In more standardized formats, it varies from about 12 characters per second to up to 20 characters per second. Specifically, Sarkowska and Garmer-Moron in 2018 found that viewers can process subtitles at even 20 characters per second while still following the images. But we also need more information on exactly how people then process this. So to do this, we designed an experiment, a 2x3 experiment, 2 video conditions with and without, and 3 speed conditions, 12, 20, and 28. We didn't use sound because we wanted to have more control, and we kept the text exactly identical across all 3 the speeds to limit the variables. Only 1 line of text. We used 6 videos for each experiment, and each of the conditions, including 1 video and 1 audio for each, and each subtitle speed had a different video, which were of course randomized. So in this design there was some redundancy in the visuals that helped people understand what they read, but not always, and it was a fairly limited comprehension test, and we've clarified that in later studies. It is so important, if you want to say anything about the impact of subtitles on comprehension, that you actually have validated comprehension scores or tests. Now, the measures we used a number of measures. Most of them are on here. Global measures such as dwell time, and that's first pass measure. Total reading times, which is the total of all the fixations. Fixation counts, average fixation duration, saccade length, all the usual suspects are there. Number of crossovers, and then also for local measures we looked at skipping, revisits, gauge durations, and total viewing times on the word frequency effects and word length effects. In global we also looked at the proportion of words that were fixated at least once and the proportion of words that were refixated. We averaged this across the videos, so of course it's not a local measure, but you need word level data for that. And then we looked at comprehension. In terms of comprehension, very briefly, very clear difference between with video and without video. The with video present, you don't see a lot of difference between 12 and 20 characters per second in comprehension, but then it clearly drops off to at 28 characters per second. Not too happy with our comprehension test, as I said, but it does give you at least the trend there, and it shows you that video actually helps people understand, and it means that with the integrated language, multimodal language framework, multimodal integrated language framework, it helps to explain that a little, because it means that you get information from more sources, you can track information. In terms of global subtitle reading, we found that the fixation duration decreased as the speed increased, the fixation count decreased. Funny things happened with saccade length in the first pass, and then also in terms of crossovers, in the video condition, at 20 and 28 characters per second, you have almost the same number of crossovers as you have in the no video condition, which is really just as soon as a subtitle appears, you go in, and after you've read, you leave it. So that already gives us an indication of the way people read it. Processing of words, it became quite clear that the proportion of words that were processed went down from 74% at the slowest rate to only 60% at the fastest rate. In other words, 40% of words at 28 characters per second are never fixated, and 31% of words at 20 characters per second. More importantly, in terms of the proportion of words that were fixated more than once, that went down from 28% to 9% between 12 and 28 characters per second, which shows you that normal reading can't really occur. Your viewer doesn't have the time to actually revisit lower frequency words. We could also, with this word level data, extract information on the proportions of the subtitles that were not read to completion. In other words, where your viewers didn't reach the end of the subtitle because it disappeared before they could. And we see that increasing from 6% at the lowest rate to 17% at the fastest rate. In terms of local measures, local word reading measures, in word frequency and word length effects, we can see that on the left is the word frequency, so it goes from very low frequency to very high frequency on the right, low left to high on the right, and what we can see on screen is the lines representing the solid lines are with video absent and the dotted lines are with video present, and you can see how that frequency effect becomes smaller and smaller as the speed increases. In the terms of word length, you see exactly the same in terms of gauge durations, which is the first pass measure, and then total times, which is a total time measure, which means it includes both first reading and then revisits. And there, in total time, in terms of word length, you can see how that really opens up, and you can especially see how there's a very small difference between short and long words and the total time spent on short and long words at the highest rate with subtitles, with video. Whereas at the slowest rate without video, there's a clear distinction between short and long words. And you see a similar trend also in terms of the frequency effect. We also looked at the frequency effect in terms of the number of revisits to words, and there you can very clearly see how this is only with video. With video at 12 characters per second, you see significantly more revisits to the low frequency words. Becomes less so with the high frequency words, but very clear difference. And then for 12 and 28 characters per second, that becomes almost non-existent. That effect almost disappears. In that low frequency words, uncommon words are fixated for exactly the same amount of time as very common words, which tells us that people are reading much more superficially. What this looks like in reality, you can see on this screenshot of one participant reading the subtitle at 12 characters per second. You can see the participant being able to go through the text, spending more time on some of the words, returning to more of the words, but then at the fast speed of 28 characters per second, the participants only really get up to the fourth word in the subtitle, which happens to be the word saliva, which is as a very low frequency if you look at any frequency counts of these words in English. And the participant gets stuck on lick and saliva, and while they're still trying to make sense of that, the subtitle disappears and they never get to reading the rest. So what are our findings from this? What we found is that in the presence of video, and as the subtitle speed increases, subtitles are skimmed, they're read more superficially, and you see that in fewer shorter fixations, more words being skipped, fewer words being refixated, in other words fewer regressions, and also fewer words subtitles read to completion. As the speed increases, the differences in the local measures start to disappear, and these local measures reflect the word frequency and word length effects mark lexical processing. So this is how we actually engage with the text, and you see how they start disappearing. And then you can also understand at this point that the combination of both the global and the local measures is what helps us to illustrate the full impact of subtitle speed on reading. If we only had the global measures, this would have been much harder to prove conclusively. So what are we doing now in our future research? Our current projects are investigating the way the impact of different levels of secondary task demand on subtitle reading. So in other words, no secondary task or an easy task where one letter just changes color and you have to press a button, and the harder task where you have to press a button when a consonant changes into a vowel. And then we want to see what is the impact on comprehension. We already have preliminary data on that, but I don't have time to discuss that. And then one of our PhD students, Sishin Lau, is also looking at video presence and visual redundancy and the presence of L2 versus L1 language audio on L2 subtitle reading. And some really interesting findings coming out of that. And in all of this, word level data is very much a key element of how we understand what we are studying. One of our colleagues, Eric Reichel, is also testing models in our attempt to show the value of the multimodal integrated language framework, and he's already shown that as the speed increases, people start skipping the shorter words, which is useful, but we're still working on the validation of that model. What it comes down to is that we've really entered a new era in eye tracking research where we can use both global and local measures to understand media accessibility and language processing. And I hope that you will be able to engage with some of this in your studies if you are interested in the use of subtitling. And I wish you the best of luck with your projects. I'm going to stop talking now, and I will be around for a few questions afterwards. I'll just put my some references on screen, but this will of course also be shared. Thank you very much for your time.